Good morning.
Good morning,
Good
ma'am.
morning.
Yeah, very good morning to all of you. See, today I'll be discussing on fourth module, that is on centroid and moment of inertia. So, centroid of plane figures. You may be knowing what is meant by center of gravity. Okay, there is a difference between center of gravity and centroid. Centroid is the property of a cross section where the area is important, but the center of gravity, it is the point where the entire mass or the weight of the body is assumed to be accumulated. And you know that weight always acts vertically downward through the center of gravity of the point. Okay, so the center of gravity can be defined as the point through which the resultant force of gravity or the entire weight of the body acts. But centroid is the point where the entire area of the cross section is assumed to be accumulated. So, okay, that is the difference between centroid and center of gravity. You know how to find out the center of gravity of some of the common figures, like flat plate when it is given. So generally, by applying the principle of moment, that is, principle of moment means by applying the Verignos theorem. So we can find out the center of gravity, because the center of gravity and the centroid both are same points, but only we are looking into the different angles. Center of gravity is the point where the objects are having weight or the mass, but centroid is the point where the objects are having area, where we can neglect the weight, but the area is important for us. Okay, by applying the principle of moment, that is, moment of the resultant is equal to sum of moment of its components. By applying that, that is the principle of moment, we can find out the center of gravity or centroid. Okay, so center of gravity of one plate, like this is given as one flat plate. So it is suspended actually. So it is suspended. So the weight acts vertically downward, and due to the string, it is suspended by means of a string. So there will be a reaction or the tension in the string, or acts vertically downward, weight acts downward. So these two collinear forces, they keep the body in equilibrium. Now if I divide this entire area into minute elemental strips, like this finite elemental strips, I am dividing this plate into first one, second one, third one, many like this. So it will have certain area, first area, second area, third area, fourth, fifth, like this. So actually I had written here, and go to my notes and show you. Yeah, see here. So this flat plate I have divided into minute elemental strips. Okay, small elemental strips. First area is having the weight W1. Okay, its coordinate distances with respect to X and Y. I'm placing this entire place in the first quadrant. Okay, the distance from Y axis is X1, and distance with respect to Y axis, that is the point. This area is located at a distance from X axis, that is Y1, X1, Y1. So its coordinates are, W1 is having its coordinate distance X1, Y1. So W2, X2, Y2. So like that, nth element, last element, we'll consider it as nth element. Wn is having its coordinate distance. This is Xn, Yn. So W is the entire weight of the plate. It is having its distance X bar and Y bar. We want to find out this point, location of this point. That is, with respect to Y axis, what is the X bar? With respect to X axis, what is the Y bar? So coordinate distance of W, where it locates. By applying the principle of moment, that is very close. Moment of the resultant. This is the resultant weight. So components of W are W1, W2, W3, Wn are the components. Moment of the resultant equal to sum of moment of its components. Now I am taking moment with respect to Y axis. So movement of the resultant, that is W into the distance X bar, W into X bar equal to, so we have divided into small elemental, W1 into X1, W2 into X2, W3 into X3, and so on, Wn into Xn. So that's what I am applying the principle of moment to this plate. So our X bar equal to, this is W1 X1, W2 X2 plus, and so on, Wn Xn divided by W. or I can write summation of Wixi. There are I element. Summation of or I or Wn xn divided by W. So I can write it as this. Similarly, y bar we can write it as summation of Wi divided by W. Okay. So this is the point where the object is having weight. Okay. That means this is not centroid. This is the center of gravity of the point. Okay. How to find out the centroid? In the same way, instead of having the object having weight, we'll convert this weight into the object having area. We'll have to find out its area. So how will you convert weight? So we can convert. We do know that weight per unit volume will give you the density. Suppose gamma is the unit weight or the density of the object. Weight divided by volume will give you the density of the object. So what is the volume? Volume will be equal to area into thickness. Area of the entire plate into the thickness of the plate will give you the volume. Area into thickness will give you the volume. Okay. AT represents volume. Okay. W I can replace it as gamma into V. Gamma into V equal to area into T. Okay. So W I am replacing by gamma T into A. Okay. So W will write W is equal to gamma A. So W1 will be now W1 will be gamma into A1 into T. The thickness of the plate will be same because you are cutting into small elemental strips W1, W2, W3 like that W1. So gamma T will be constant. Gamma T into A1, gamma T into A2. So Wn will be gamma T into AN. So I can write all these W equal to gamma T into A, capital A. W1 I can write it as gamma T into A1, gamma T into A2, gamma T into AN. So I have written gamma T into A into X bar equal to gamma T into A1 into X1, gamma T into A2 into X2, so on, the gamma T into AN into X1. So X bar equal to, so here gamma T I can cancel throughout. So I'll be left with the gamma and T we have cancelled throughout. So the X bar equal to A1 X1 plus A2 X2 plus and so on A1 AN XN divided by area. Or I can write X bar equal to summation of AI Xi by A, summation of A. So this equation is in terms of area. Earlier equation, this equation in terms of weight. Weight. So this is the point where center of gravity. We call this point as location of the center of gravity. This in terms of area, we call it as centroid. Only that is the difference. But the point remains same. Center of gravity or the centroid. The point remains same. Location of that point is also the procedure remains same. But we looked into the different angles. So when the objects are having weight or the mass, we say it is center of gravity. When the object is having area, then we call that point as centroid. Okay. So we'll see the centroid of some of the common geometrical shapes. What are the common geometrical shapes we can see? Circle, rectangle, triangle, or semicircle, quadrant. These are all the some of the common geometrical shapes. So where the centroid of the circle having radius r lies. So when the r is the radius, area is equal to pi r square. So pi r square is the area of the circle. Where the centroid of the circle lies. So centroid of the circle always lies at the center. Okay. Having diameter d or the radius r, centroid of the circle always lies at the center. In case of rectangle, having width b, depth d. So where these two diagonals are meeting, centroid of the rectangle lies where the two diagonals are meeting. So this will meet at distance of half of the depth, d by 2 or b by 2 b by 2. So centroid of the rectangle lies where the two diagonals are meeting, that is from the edge. Suppose if I consider x and y axis passing through this edge, so b by 2 and d by 2. So for triangle, so we have used for finding out the support reaction when the load is in the form of a triangle. What I said, so it will lie at a distance of 1/3 of base or from the where it is forming 90 degree, or 2/3 from its apex point, 2/3 of base, 1/3 of height and 2/3 of height. Or we can say geometrically, or it is if I draw three medians of the triangle, where the three medians are meeting, that point will be the centroid of the triangle. So we can derive it from the first principles. We can locate this centroid from the first principle by integrating. So that we'll have to see. So for a triangle where the centroid lies, how we can arrive this is 1/3 of base or 1/3 of height. For semicircle, it will be different. For quadrant, it will be different. So we can derive it and see. So here the simple derivations are given. The derivations are also important. So okay, whenever the symmetry comes into picture, using, so the difference between centroid and center of gravity is given. So I have uploaded this entire textbook notes also. Okay, you can go through that notes. So whenever the symmetry means exactly at the center, if you pass a line, left hand portion is the mirror image of the right hand portion, or upper portion is the, with respect to x-axis, exactly at the center, if you say, take upper portion is the mirror image of the lower portion. So then the centroid always lies where the two axes are meeting. X-axis also, if it is, there is a symmetry, axis of symmetry exists. Y-axis also there is axis of symmetry. When then in that case, centroid lies at the center. You can see in case of circle. See, if I take exactly at the center, the x-axis, exactly here y-axis, those two axes, because this upper portion is mirror image of this. If I hold it exactly here, this line, it will coincide with respect to this. Similarly here also. So that's why we say whenever the axis of symmetry is existing, so where those two axes are passing, there the centroid lies. Here also it is same thing, b/2, d/2, exactly at the center. Okay. Then for triangle, we can't say whether there is no axis of symmetry, either right angle triangle or any shape, any type of triangle, isosceles triangle or any shape, right angle triangle if you consider. How you can derive it by using the first principle. Okay. So first what we need to do, we have to select the axis, x and y axis. So x axis passing through the base. This triangle is having height h and base b. Okay. So what we need to do, we have to assume one triangle. What I have done it on my own way. So by taking the right angle triangle, okay. So we'll locate it from the first principle. I have taken x-axis passing through the base, y-axis passing through this. Okay. Then what we need to do, so we'll have to take one small elemental strip. Assume one small elemental strip of thickness dy and its base b1. Okay. This entire triangle is having base b and height h. Base b, height h. Then the area of the triangle will be equal to half into base into h. Area of the entire triangle given equal to half into b into h. Now one strip I have assumed, this strip is located at a distance y from the reference x-axis. Reference x-axis is passing through the base. Okay, at a distance y. Then this, if I deduct from h, if I deduct y, the upper portion will be h minus y. Okay. Now I need to get this b1 in terms of b and h, base. This strip is in the form of rectangle now. Here there is small inclination that we can neglect it. We can consider this strip because it is a small finite elemental strip. This small projection you can neglect it and consider this strip is in the form of rectangle. Then the area of this elemental strip will be b1 into dy, since we are assuming it is rectangular shape. Okay. Then b1 into dy is the area of the element equal to b1 into dy. Now b1 I have to write in terms of h and y. That is from similar triangle. This entire triangle, if you take, h is the height for base b. From similar triangle, h is the height for base b. Another triangle, this upper triangle above base b1. This is another triangle. So h minus y is the height for base b1. H minus y is the height for base B1. Now I have to write for expression for B1. What is B1? B1 equal to B into H minus y divided by H. B into H minus y divided by H. So B1 I have represented in terms of H and B. Okay. This strip is located at a height of y from the base. So the height above the triangle. So this will be H minus y. So from similar triangles, H is the height for base B, H minus y is the height for base B1. Then B1 I can write it as B into H minus y by H. So here I am substituting B1. B1 equal to B into H minus y by H into this dy. This is the area of the element. Okay. Now, so this area of the element dy. So as per the centroid, so we can write x bar equal to summation of ai xi divided by summation of a. Or in terms of integrals, I can write it as x bar equal to integral x into dA divided by a, or y bar equal to integral y dA divided by a. This is in terms of the integrals we can write, where integral dA is capital A itself, y into dA, that is the first moment of area. We call it as distance multiplied by the small elemental area. This we call it as first moment of area, or moment of area, or first moment of area divided by total area. This is centroidal location of any area. Y bar represent with respect to x-axis. So this, so the centroid of this entire triangle with reference to x-axis, that is y bar equal to integral y dA divided. This is the general formula. Okay. So y bar equal to integral y dA. Y is the location of this strip. Okay. The strip is located at a distance y itself. Here also we have taken y. Y into dA. dA is this area of the element. dA equal to b1 into dy, or b by h into h minus y into dy. Okay. This one, madam class mugisi madla. Iga 5 ನಿಮಿಷ mugisi. Okay. I will call you. The b by h into h minus y into dy. This is the area. So y into dA. dA I have written b by h into h minus y into dy, and divided by capital A is half into bh. This equation we got. Y bar equal to y into dA divided by capital. So now we'll have to, this is the integral. Y into b by h. B is constant base. Only the variable is y. Y is variable. H and b are constant. So y dy, you can take y dy on the other side. B by h is constant. H minus y, y dy. So then integrate it. So what is the limit for this integration? This y can vary from, I have taken from the x-axis. So this is the base actually. So I have taken from here to y. So y can be this strip, I can take it here very close to base, or very top level. Here also I can take. So the limit for this y varies from here to here, from this point to this point. So that is from 0 to h. So limit for this integral varies from 0 to h. So this 0 to h I have taken. So limit for the integral varies from 0 to h here, 0 to h. Now you integrate this equation, y b by h into h minus y. Y b, I have just opened the bracket divided by h. So you parallelly you are studying mathematics also, you know how to do the integration of this equation. Okay, I just integrated, simplified the equation, and half bh divided by half bh is there. So finally, if you simplify this, you will be getting h by 3. Okay, only the formulation of this equation is difficult. Once you formulate this equation, then simple integration part. Okay, so this is the way I have done it, or you can refer the book how they have solved the same way. You can see this. Okay, any shape they have taken. So b1 is the base for they have taken other way. B1 is the base for this small strip, because B is the base for this. So for this base, height will be h minus y, and for this base height will be h. So B1 they have represented. So same way I have done. Area of the element will be B1 into dy. They have represented like moment of the area divided by total area. Integral y dA. So integration part. Okay. Finally, even they have got it as h by 3. So like this, we can find out. So y bar equal to h by 3. From the base, the centroid of the triangle is lies at a distance of h by 3. Thus, this is the centroid of the triangle. Similarly, x bar also we can do by taking this strip parallel to y-axis like this. That is not required. Only one, if you find out either x bar or y bar, it is enough. So, in the same way, you can write y bar, x bar also equal to other way around, b by 3. Okay, this x bar from with respect to this, it will be b by 3. So, you can show only y bar. Y bar equal to h by 3. This is for the triangle. So triangles, this is one of the theory question you can expect. Derive the expression for the centroid of the triangle. Okay, centroid of the triangle, centroidal location of the triangle. So you have to assume one triangle having height b, base b and height h, and then apply the principle of moment, integrate it, and finally we arrive y bar equal to h by 3, x bar equal to b by 3. You can write x bar, y bar are the centroidal location of the triangle. In the same way, we can also locate the centroid of a semicircle. Semicircle is another simple geometrical shape, half of the circle. So for circle, you know, centroid lies at the center of the circle. In case if it is in the form of a semicircle, where the centroid lies. Okay, so the x-axis is taken passing through its diametral axis, y-axis exactly at the center. Now you can observe y-axis is the axis of symmetry, because this, if I take exactly at the center, this left-hand portion is the mirror image of the right-hand portion. Okay, so centroid lies on this axis. Where it will lie, because x-axis if I take exactly here, this upper portion is not the mirror image of the lower portion. Okay, so we'll have to find out from this x-axis where the centroid of the semicircle lies. So only you know that x bar equal to 0. What is y? X bar equal to exactly half of the diameter, or at r itself, radial distance itself. Only with respect to x-axis where the centroid lies on this axis. Okay. For that, what we have done, we have assumed one semicircle having radius capital R. Okay, assume one, consider a semicircle of radius capital R. It is symmetric, centroid lies on the y-axis because it is symmetric with respect to y-axis. Okay, now we'll assume one small strip, okay, like this, rectangular strip. The strip is at an angular distance theta, which makes, if I continue this and if I join both the edges to the center, it makes an angle d theta at the center. This strip is making an angle d theta at the center, and it is at radial distance r. Capital R is the radius of the entire semicircle, and this strip is located at angular distance r, and radial distance r, angular distance theta. That is the construction. Okay, you have to remember thickness of the strip is dr. Once the thickness of the strip is dr, this angle made at the center is d theta and r is the radius. Then what about this arc length? Arc length will become r into d theta. R into d theta is the arc length, dr is the thickness. Then area of this rectangular strip will be equal to dr into length is r d theta. R d theta into dr, area of the element. Okay, r d theta is this arc length, r d theta into dr. R d theta into dr is the area of the element. Okay, what is the area of the entire semicircle? The entire semicircle area will be equal to pi r square divided by 2. Pi into capital R square divided by 2, half of the circle. That is pi r square divided by 2. Okay. Now, what we need to do, I'll go to my notes at the end. this. Okay. So I have assumed one small rectangular strip at an angular distance theta, and this is the radial distance r, which makes an angle d theta at the center. So r d theta is this. So my strip I have just taken out. Dr is the thickness, r d theta is the this. So this is the area of the element. Dr into r d theta is the area of the dA equal to dr into r d theta. Because see, this r is the radius d theta, so this arc length will be r into d theta. That's why the area of the strip becomes dr into r d theta. So you know that y bar equal to integral y dA by a. So we have assumed from the diametral axis, the strip is located at the height of y. Okay, this is this we have assumed at a distance y. Now you know that this angular distance theta and this is r. I have taken here. See, you can see this is y. Y equal to, so this hypotenuse length is r. This angle theta. So the opposite side y is equal to r sine theta. Y becomes r sine theta. Okay, this y is equal to r sine theta becomes this vertical drop. If I draw here, this height will become r is the radius, theta is the angle, y is equal to r sine theta. It becomes now. So y equal to r sine theta, dA equal to dr into r d theta. So y bar equal to a equal to pi r squared by 2. A is equal to area of the semicircle pi r squared by 2. So y bar equal to integral y dA. So integral y dA, y is r sine theta, dA is r dr d theta. Okay, since you can see there are two variables, dr and d theta. R is also variable, theta is also a variable. There are two variables, r and theta. So we have to put double integral, one for r, one for theta. Now you know that r varies from, so here we have taken r, small r to capital R. 0 to capital R. R varies from 0 to capital R. And theta, I have assumed from here, this theta I have taken from with respect to x-axis. So from here to here, like this, entire angle. So theta can be from 0 to 180 degree, or it will be 0 to pi radians. In terms of radians, we have to 180, 0 to pi. For this limit is for theta, 0 to capital R, this limit is for r. Okay, now I am taking r terms together. So r into r. So r squared dr, 0 to r, 0 to r squared dr. So if I integrate r squared dr, r cube by 3, 0 to r. Then this theta terms together, sine theta d theta. So 0 to pi sine theta d theta. So r cube by 3, 0 to r. So I have substituted small r to capital R cube by 3. Sine theta d theta will be equal to 1 minus cos theta. Sine theta is minus cos theta, 0 to pi minus cos theta. So you will be getting 4r by 3 pi finally. If you simplify this equation, integrate it, simplify, you will be getting 4r by 3 pi. Because the denominator you have pi r squared by 2, this numerator and denominator. So like this, you can find out the centroid of the semicircle. Okay, this is the centroid of the semicircle. So go through these notes. Okay, this is centroid of semicircle. Centroid of another simple figure is the quadrant of a circle. So everything remains same. Construction, whatever we have done for the semicircle, exactly it remains same. But only the thing is here 0 to 180 degree. So if it is a quadrant, quarter of a circle, only half portion, you can observe. So only the theta value varies from, limit for theta, it varies from 0 to 90 degree or pi by 2 radians. All other, everything will remain same. Okay, only that is the difference, 0 to pi by 2, and the other one 0 to capital R squared sine theta dr d theta. Only limit for theta it varies, 0 to pi by 2 it becomes, or else exactly similar equation, only the limits are different. Once 0 to pi by 2, so this term will change. But final equation here also we will be getting 4r by 3 pi. 4r by 3 pi itself. So either so from both axes, 4r by 3 pi, centroid of quadrant distance of 4r. Ankita, any doubt? Anybody is having any doubt regarding the centroid? These derivations are also important, okay? Please go through the notes. I will be uploading now. So whatever the notes here I am showing. So the location of the centroid, this is not important. Only the theory you should know, that's all. It won't come. But this is important. You should know about the difference between centroid gravity and centroid. And this location of the centroid of a triangle is important. Centroid of a semicircle is important. Centroid of quadrant is important. Sector of a circle you can leave. Centroid of sector you can leave it. Don't study about the sector of the circle. Okay. Next we'll work out. You know that the now whatever we have seen. See, centroid of the triangle I had given in the book, it is given in the table form. Triangle, okay, x-axis taken passing through. That is very important, where you take the axis. With reference to the axis only, you can locate the centroid. With respect to x-axis, so x bar, it is shown because it was not shown, only h by 3. With respect to x-axis, it is shown h by 3, and area of the triangle is half bh. So semicircle, it is shown here because y-axis is the axis of symmetry. That's why it is shown because centroid lies on that axis. And with respect to x-axis, it is 4r by 3 pi, and the area of the semicircle pi r squared by 2. For quadrant, 4r by 3 pi from both axes you will get 4r by 3 pi, 4r by. And the area of the quadrant will be half of this. So that is pi r squared by 4. So you can remember pi r squared is the area of the circle. Half of that is the area of the semicircle. Again, half of this will be area of the quadrant. Pi r squared by 2, pi r squared by 4 is the area. So you have to remember these equations. H by 3 is the centroid location of the triangle. 4r by 3 pi in case of semicircle. So 4r by 3 pi in case of the quadricircular area. Okay. Next, tomorrow's class we will discuss about the problems. Problems I have not considered in today.